In my last video, I poked around inside the main electrical panel and connected up an ESP32 with some current transformer clamps, and I tracked every single watt coming into my house. But let's be real, opening up a live electrical panel can be intimidating. And if you're renting or you just don't want to pay for an electrician, it's a non-starter. But what if I told you my utility company is already broadcasting my detailed energy usage right through the air, completely unencrypted? And what if I could read that data from my couch using a cheap software-defined radio dongle? My name is Zach and I'm the Byte Sized Engineer. In this video, I'm going to show you how to use an RTL-SDR to sniff my smart meter's radio signals, decode that data, and track my power consumption without touching a single live wire. Here's a high-level overview of what I'm trying to do. The data that I want to capture is being broadcast over the air, so I'm going to use one of these software-defined radios connected to an antenna to capture those signals. But a software-defined radio doesn't work on its own. It needs to be connected to a computer. Once I get all of these parts connected together, I'm going to use an open-source software to parse the data into a human-readable format. I've got a couple of options that I can use for software-defined radios. The first one here is the HackRF1. This one has a lot of features, but it also comes with a little bit higher price tag. It can both transmit and receive data, and it's a little bit overkill for this project. The second option is the RTL-SDR. This one has fewer options. It can only receive data, which is all we need for this project, and it comes at a much lower price tag. For those reasons, I think I'm going to choose the RTL-SDR for this project. Before I get started, I've come out to my utility meter just to make sure that it's a newer style that is broadcasting the data. While I'm here, I'm also going to look at the barcode number because I don't want to confuse it with the readings from my neighbor's panel. Did I forget to mention that? Yes, I can also read the power usage of all of my neighbors, which can come in handy if I want to make a comparison to see if I need to change any of my own habits. I'll take a quick snapshot here and we'll head back inside. Let's go ahead and get this thing assembled. I'm going to start with the tripod and then I'm going to screw in the dipole antenna base. This kit comes with two sets of antennas. I'm going to use the shorter set because I know that my signal is 915 megahertz and I want to tune these antennas to be the right length so that they receive that 900 megahertz signal really loud and clear. Next, I'll connect the antennas to the SDR using an SMA connector. And I'm looking at the quick start guide and it looks like I need to install something called AirSpy SDR Sharp. It was a little tricky and it involved running some batch scripts that replace the drivers on my Windows desktop, but I think I've got it working. Here's what the software looks like. At the top, I've got my frequency range on the x-axis and then my signal strength on the y-axis. Down below, this giant ocean of blue is my waterfall chart. And anytime we see a dark contrast area in the waterfall, that means that there's a signal there. I could use my desktop or a laptop for development, but since I know that my ultimate goal is to measure and monitor this data using Home Assistant, why not just use the Raspberry Pi that's running my Home Assistant as the computer for this project? If I can get this to work, it's going to be so much better to have this plugged right into the Raspberry Pi than some other computer having to run 24/7 to collect the data and then send it to Home Assistant. I've done a little digging and I think I've found a GitHub repository that actually does all of this work for me. Supposedly this code will actually capture all of the smart meter data, package it all up, put it in human readable format, and put it right into Home Assistant. If this works, that is going to save me an enormous amount of time. And can we just take a second and give a moment of appreciation for the maker community? There are so many people out there who build really cool projects like this. They give up their nights and their weekends to build something and then freely share it with the rest of us so that we can all benefit. That's a really amazing thing, and I think that we take it for granted sometimes. Thank you to everybody out there who has given up your own time and your own efforts and shared your work freely. With that said, and the SDR connected to the Raspberry Pi, I'm ready to try to install this Home Assistant integration. Here's the GitHub repository for this Home Assistant integration. It's called RTL-AMR to MQTT. I know that's a mouthful and a lot of letters, but basically it's code that reads utility meters. This isn't just for smart power meters, it also works on smart meters for water and natural gas. How cool is that? I won't get into the nitty-gritty here because if you're interested, you can do your own reading. But basically, this works by running RTL TCP to interface with the SDR hardware and running RTL AMR to decode the meter transmissions. Then the readings are parsed and forwarded to MQTT in real time. If all of that sounds like gibberish, don't worry about it. All it means is that all of the complicated radio stuff is being handled in the background and we just get to see our meter reading right in Home Assistant. To install this in Home Assistant, I scrolled down to the installation section and I found that there were actually buttons to add to my Home Assistant. However, when I pushed them, they didn't work. Maybe there was something I did wrong on my end, but not to fear because the next section tells you how to do it manually. There's a recent change in Home Assistant, and instead of calling them add-ons, they now call them apps. So if you see things that say add-on, just know that they're now called apps. I followed the instructions and I opened up the app menu and I clicked on Install App. And then in the upper right-hand corner, I clicked Repositories, and that's where I can install a new repository based on a GitHub URL. Once I've installed the app, I can click on the Configuration menu, and then I click General. Down at the bottom of the General menu, there's a little switch that says Listen Mode. I'm going to turn that on, and what it's going to do is it's going to print out all of the smart meters that it can find. I want to make sure that the barcode in the picture that I took earlier on my meter matches the meter that I'm reading. The worst thing I could do right now is mix up my data with my neighbors, and then it would be really confusing. This app relies on an MQTT broker, and since I don't have one of those installed in Home Assistant, I need to do that first. One of the most popular MQTT brokers is called the Mosquito Broker, and you can install that right from the App Store without having to paste in an external URL. Now that the RTL-AMR add-on is running, I open up Log, and it starts printing out all of the new meters that it finds. And right here I can see a meter ID that matches up with the barcode on my meter, so that's a really good sign. I'm going to copy that number down, and I'm going to come back into Configuration, and I'm going to add a meter at the bottom. First, it asks for the ID number, so I put that in, and then it asks for the protocol. If I look at the log again, it shows that my meter is sending IDM data, so I'm going to put that as the protocol. Then I'm just going to name it Power Meter. I'll also set the device class to Energy and the state class to Total Increasing. This is important. I'm going to go back to General and I turn off Listening Mode because I don't want to capture all of the information from all the meters. I've now set my meter and I just want to listen to that one alone. With all of this information set and saved, I'm going to restart the service, and then I can go back into my devices, and I see that I have a new device discovered in my MQTT broker, and it's my power meter. The current power meter reading that it shows matches the one on the display outside, which is really cool. You might be asking yourself, why should I use a software-defined radio to read my smart meter? What information is it giving me that I can't already find out from my utility bill? First, let's take a look at what Home Assistant knows already. Here's the raw value that it's getting from the smart meter, but I'm noticing a difference between this number and what I'm reading on the actual meter itself. The display on my meter outside rounds to the nearest kilowatt hour, but luckily we get a little more precision with the data that it broadcasts over the air. The raw value gives us 2 more digits, but we need to put those behind a decimal place. So let's dive into the Devices and Services menu, and then I'm going to click Helpers and Create Helper. I just need to create a template sensor to position the decimal place where it's supposed to go. The code that I wrote in this box grabs the raw sensor value, divides it by 100, and rounds it to 2 decimal places. I also made sure to set the units to kilowatt hours, the device class to energy, and the state class to total increasing. Now I can look at the raw value and compare it to the template sensor we just created, and I can see that it's formatted correctly, the decimal place is in the right spot, and we've got the right units. Here's where things can get really interesting. Let's create a new helper entity, and this time we're going to make it a utility meter. In Home Assistant, a utility meter helper is just a value that resets periodically. In this case, I'm going to have it reset every month, and that way it will keep track of my monthly energy use so far. So if today is May 10th, for example, it will show me how much energy I've used so far in the month of May. I won't stop there. I'm going to go ahead and create more utility meter helpers for weekly energy, daily energy, and hourly energy. All of these values will reset back to 0 monthly, weekly, daily, and hourly respectively. So far, these numbers are really helpful, but what if it's the middle of the month and I want to know how much energy I used over the last 28 days? I need to set up a statistics helper that will keep track of changes over the last month. Once I've got that in place, I'll do the same with statistics helper for the last week, the last day, and the last hour. With all of these in place, I've got a huge amount of information at my disposal. Without these helper entities, it's kind of pointless to use a software-defined radio to read your smart meter because you could get the same information by just coming out and periodically checking the meter. By tracking this information over time in Home Assistant, I can get a lot more detail about how much energy I used in the past hour, in the past day, in the past week, and so on. I can't get that same granularity by looking at my electrical bill. Now it's just up to me to use this information how I want. I can track it over time, I can put it on a dashboard to make it pretty, I can use it for automations and all kinds of stuff. So how does reading over-the-air signals with a software-defined radio stack up against the current transformer method that I used in the previous video? I think it kind of comes down to convenience versus granularity. There are so many good things about the software-defined radio approach. It's fairly cheap, pretty easy to set up, and you don't have to worry about opening your electrical panel. But there are also downsides. You can only read your home's total energy consumption, and you're also at the mercy of how often your meter transmits, which in my case was every minute or two. On the other hand, using current transformers inside my panel gave me so much more clarity and transparency on my energy usage. I can connect one of these to every single branch circuit that I want to measure, and I get real-time, second-by-second data. But this took a little bit more effort to build and install. And that's kind of the wonderful thing about engineering, is that often there's more than one way to solve a problem. And usually there are trade-offs between each different solution, so you just need to weigh those trade-offs and decide which one is right for your project. As always, I'm going to have links to all of this stuff, so check out the description if you're interested in doing this yourself. My name is Zach and I'm the Byte Sized Engineer. Thanks for watching, and I'll see you next time.